Hi, I'm Dr. Neenu Garg, and in this session, I will give an example for preemptive priority scheduling algorithm. Let's see the example. As you can see, there are 4 processes in the system, and we have been given their arrival times, burst times, and their priorities. So we have to use priority scheduling algorithm and find the average turnaround time, average waiting time, schedule length, and throughput. So let's see. At time 0, this I'm plotting a Gantt chart. You must have known this thing that we always start with plotting Gantt chart. At time 0, there is just one process in the system, P1. So P1 will be scheduled by the scheduler. P1's burst time is 4. At time 1, its remaining burst time is 3. So at time 1, there are 2 processes in the system, P1 and P2. Priority of P1 is 3 and priority of P2 is 2. Because at time 0 there was no choice, that is why P1 was scheduled. But now at time 1, scheduler has a choice among P1 and P2. P2 has low priority, so P1 will be preempted and P2 will be scheduled. Okay. So P2 will continue to execute till 3. But sorry, P2 will continue to execute till 2. At time 2, there is another process, P3 in the system. But the priority of P3 is 4. Therefore, P2 has still least priority. So CPU will not be preempted and P2 will continue its execution till time unit 3. At time unit 3, P2 complete its execution. Keep looking at burst time. It is just 2 units. So P2 complete its execution. P2 is done. At time 3, there are 2 processes in the system, P1 and P3. Among these 2, P1 has low priority. So CPU scheduler will select P1 and it will continue to execute till time 4. The remaining burst time of P1 at 4 is 2. Okay. At time 4, P4 arrives in the system and its priority is 1. And generally, I have not mentioned, but generally lower number is high priority. I should have mentioned it, but please take it granted. In the numericals in slides, lower number, high priority. So at 4, P4 arrives and it has priority 1 and low number, high priority. So CPU will be preempted from P1 and it will be allocated to P4. And it will continue to execute till 5. It is important to note that when all the processes have arrived in the system, preemptive priority scheduling algorithm behaves as non-preemptive priority scheduling algorithm. Till 5, after this no more processes are arriving in the system. So P4 will continue to execute till 6 because its burst time is 2 units. Now P4 is done. There are 2 processes left, P1 and P3. So P1 will be scheduled because its priority is less than P3. It has just 2 burst time left, 2 units. It will continue to execute till 8. At 8, there is just one process which is left, which is P3, and its burst time is 3. So it will continue to execute till P3 will execute till 11. Okay, so you can just ignore this line. So this is the Gantt chart. From here, we can find out the completion times. Now, completion time of P1 is, if you see from this chart, completion time is 8. It is point in time. Completion time of P2 is 3. Completion time of P4 is 11. Completion time of P4 is, yes, it is 6. Now, turnaround time is completion time minus arrival time. So we will find out this. For P1, it is 8 minus 0, which is 8. These are all in milliseconds, okay? For P2, it is 3 minus 1, which is 2. For P3, it is 11 minus 2, 9. For P4, it is 6 minus 4, which is 2. Okay. You can find out average turnaround time. Average 8 plus 2 plus 9 plus 2 divided by the number of processes in the system, which is 4. Let me compute this for you. It is 21 by 4. So it comes out to be 5.25 millisecond. You can verify it also. Let's see waiting time. Waiting time is turnaround time minus burst time. For P1, it is 8 minus 4, 4. For P2, it is 2 minus 2, which is 0. And for P3, it is, yes, 9 minus CPU burst time is 3, which is 6. For P4, it is 2 minus 2, which is 0. 4, 0, 6, 0. From here, you can find out average waiting time. 4 plus 0 plus 6 plus 0 divided by 4, which is 10 divided by 4, which is 2.5 millisecond. Now schedule length. Schedule length, we all know, you must have learned. Completion time of last process minus arrival time of first process. You can refer previous videos for better understanding of schedule length. So it is the time during which scheduler is active. So last process completion time is 11. 11 minus starting, when it started 0. So schedule length kitni aa gayi? 11 milliseconds. Okay. It is duration in time. And last is throughput. Throughput is number of processes divided by schedule length. Basically, we want to find out number of processes completed per unit of time. So it is 4 divided by 11 processes per unit of time. Okay, so this was all about the preemptive priority scheduling algorithm example. I hope you understand the session. Thank you.